Hi, I'd like to welcome everyone to the October SPWLA The More You Know webinar series. Appreciate the opportunity. My name is Don Herman. I'm the manager of U.S. Sales and Corporate Business Development for Cordax, and we are thankful that we have the opportunity to be the webinar series host for this month. I'm going to go through what is Cordax, what is it we do, and how we can help operators improve their efforts. My contact information is on the slide, so if anyone has questions or would like more information or would like us to set up a job, which would be great, I have my email and my cell phone, which you can call or text or email at any time. So I appreciate everyone's joining us. Darby Witt is our completions manager, and he will be part of the Q&A with me, and we'll look forward to meeting you in the future. So LWT is what we do, and that stands for logging while tripping. And I'm going to kind of go through this a couple of times, but in effect, it's an opportunity to go back to evaluating all wellbores with a system that's been around for over 100 years called logging. Our system is different. But it's not new. It's not a startup. We have been around a while, and the technique is industry proven. It's patented to Cordax, and what it is a very low cost, safe methodology to get open hole logs. And we've done over 1,300 jobs globally, and I'll go through some of the history of the company in a bit. We've qualified the data with more than, at this point, 36 log ops, which are comparisons against the industry standards of Schlumberger wireline, Through-Bit, Weatherford, Shuttle, Halliburton, Baker, LWD. We've really tested it against all known industry methodologies, and we're accepted by lots of folks. We've done a really good job of getting Cordax known kind of in the geoscience arena, and we're really focusing on growing the knowledge base in the completions area as well. And it's really no wires. We eliminated wireline, so we get you logs without wireline. No worries, it's completely safe. No issues with the dreaded thought of leaving sources in an open hole, and no waiting. We log on the TD drilling run, so you don't have to pull out of the hole, go back in, condition the well, rig up wireline, hope you get down. We eliminate all that. So it's very much an efficiency system as well. It's, like I said, open hole logging has been around a long time. And really, some of the issues that come with wireline logging is the costs, added rig time, added time a well is open, causing lots of anxiety, risk of potentially sticking tools, especially sources. And by eliminating wireline, we can really provide similar answers at overall maybe 10% of the cost people are used to paying. So it's a safe, cost-effective methodology to get open hole logs. And the key thing is it doesn't matter to us what kind of well it is. And if you look at how the business is evolving, we really can log anywhere you can get a bit to TD. And it's conventional wells. We do a lot of vertical wells, which is pure wireline replacement, and particularly in difficult wellbores, ledges, where you have to make multiple trips with drill pipe, maybe multiple wireline attempts. You can now drill it, drop the tools, get the logs. Unconventional wells is where we put a lot of our horsepower in developing answers of, okay, you drilled a lateral, got 2 miles of earth, and you either don't get any information or you choose to get information, and this is a way to do it cost effectively and safely. doing a lot of work with saltwater disposal wells, gas storage wells. Honestly, it doesn't matter to us. It's if you need data, it's low cost, low risk, little rig time, and if you want, you can log every well again. One of the things I want to do with this talk is really dive in a little bit on what we call our goal system, which is geologically optimized limited entry completions. And that's a fancy way for saying with data, we can reduce your completion costs dramatically. And it's something that we can give you a full-blown deep dive presentation on all of the details. This presentation really just covers some of the highlights, but it really allows you to see the rock because geology changes, understand the rock, what's the facies changes, what are porosity changes, saturations. And really, we say frac with purpose, which means put a little bit of money into understanding the geology, and you can save a lot of money on the back end on your frac operations. So again, we like to look at developing partnerships with our clients. And it's not just a one-off science program. It's what we look at it as a continuous improvement system that allows operators to, now you look at what's left to reduce completion expenses. And, you can only wring so much out of the service companies, and that's pretty much up against the wall now. So how else can you reduce completion expenses and still treat the same amount of well that you want to treat? And by using this system, it allows you to do it. And it allows you to improve cluster effectiveness, completion efficiency, pump time, fluids pumped, and really at a low cost, low risk, little rig time, you can get a big return. So the paradigm mental shift is, okay, yeah, there is a cost and it goes to the AFE, but at the end of the day, if you have a little cost with a big reduction, your AFE goes down. So it's not additive, it helps on the business side. We have a new system I'm going to touch on, which is really a new way of evaluating cluster effectiveness. We've done a project in the DJ. We have projects in the Bakken and the Permian teed up, and it's a very low cost, continuous methodology that you can use to evaluate your effectiveness and get better. So at a real high level, for all of us, service companies, operators, everybody in the business chain, to win, we can't keep doing things the same old way. And to do things differently, Cordax provides a vehicle to really make better ROIs for investors a reality. So what I want to look at is little details on the goal and the completion optimization. And really the current situation is $40, $45 oil, whatever the price is, we have to get better and we have to improve to make money in that environment. And Lord willing, prices doubled and we all benefit. But in the meantime, what are we going to do in the current environment? And really, the things in the equation is so simple. It's you got to either lower costs or increase production or do both. And if you look at the cost breakdown, estimates are roughly 60+% of the money spent goes to completions. So if you're focused on can you reduce that and get the same or better results, you're money ahead. And one of the ways to do this, and again, we're kind of approaching this simplistically. Yes, there's science behind it, but at the end of the day, if you can get the same number of fracs with fewer stages, get the same amount of fluid pump, same cluster count, similar performance, why not? And that's what this system does. So your choices are varying stage lengths blindly or by using data. And by using data, you can really understand the geology. And I've got an example of a Permian program we did. And at the end of the day, it's simple. When geologically appropriate, make longer stages, less fracs, lower cost. And by understanding the geological properties, you can really manage the perf design to optimize cluster efficiency and fluid distribution. And, we call it our Cordax. Our goal is to improve completions. For those that don't know about Cordax and our system, I've got a little bit of background on the company. And, we look at well logging. It's been around forever in this business. And we draw an analogy to content distribution that every generation, every economic downturn, every technology disruption creates a massive change in how we do things. In content, 4 generations ago, we had a cinema, and then finally it got sound, but you could watch one movie, and it morphed to TVs, to Blockbuster, which is the greatest thing ever, which is now dead, to Netflix, which is really the wireless cinema. Only you can see everything and anything anywhere for not much money. And that's kind of the evolution of logging. That our dear heroes, the Schlumberger brothers, started this over a century ago. Myself and my partners at Cordax, we all started out as wireline field engineers with Schlumberger and moved through the industry. But for 100 years, every well that got drilled got logged. And it was done with wireline, and it was an industry accepted practice. And there was a reason to do it, and that was to understand the geology and better manage completions. Kind of migrate to the 70s and early 80s, offshore was booming, salt dome drilling, high angle wells, heavy mud weights, and this propensity of wireline tools to not come out of the ground. So once you stick a wireline tool string and have to pay for that, plus pump the pink cement to get rid of the source problem, and it costs a lot of dough. So LWD, logging while drilling, evolved, and it was a good system. It's expensive, and you still have the issue of if you stick your drill string, you now have a 7-figure ticket for the LWD tools, plus sources buried in the hole. So that was really the drawback. Then, back in the 2010 timeframe, there was a couple technologies that commercialized, one being ThruBit and the other what became the Weatherford Shuttle. I was on the introduction team of ThruBit in the Permian, which was, the company really started lateral logging, and Weatherford also was there at the same time. But even then, you still had the risk of sources in the open hole and 2 to 3 days of additional rig time, which, operators did not want to do. So where you could get data, it was still very expensive, risky, took a lot of time. And then you go to the next step is the wireless world of Cordax, where we now put collars in the drill string, drill the well, drop the tools, no wireline, pump them out, and as you're tripping out, you're logging the well. So it's logging while tripping. It's not new. Company started out as a company called Datalog in Canada. Mud logging company, mineral logging, heavy oil sand stuff in Canada. And Datalog developed this collar logging technology. Prior to 2011, when this Cordax technology commercialized, pretty much all the jobs were in Canada. 2013, the owners of Datalog moved into the U.S. in the Bakken and Oklahoma. 2014 and 15 hit and pretty much killed that dream. And our management team, our chairman and our board bought the technology in 2015 and rebranded the company as Cordax in 2016. I joined at that time to basically take the U.S. business that went away and rebuild it. And since then, we've done more than 500 jobs in the U.S. Overall, we've done 1,300 plus jobs, so it's a proven technology. And this client list is some of the folks we've worked for, not all. And these are some of the folks that have done comparisons of our data versus all the other companies in the business. And it's industry quality open hole data. I'm going to go back a step. I'm going to show a short animation, and when that's done, I'll be back. This is how the system works.
The Cordax logging while tripping methodology helps all operators improve their return on investment by reducing completions costs and improving well production. Logging while tripping eliminates any argument to not log your well. The Cordax steel collars are inserted into the bottom hole assembly during the final bit trip. The all-steel API-rated drilling rated collars allow you to complete drilling your final leg. At total depth, the logging process begins immediately. Using the rig's mud system, the logging tools are pumped down and latched into place within the Cordax steel collars. The logging tools are acquiring data in memory as the bottom hole assembly is tripped to surface. Any operational challenges can be alleviated during the trip. Once the logging tools are back on surface, standard prints are generated. Advanced processing unlocks the potential of the granular dataset. The operator can hone in on key components of their wellbore that can greatly affect the well cost and well performance. Along the bottom, the Cordax dataset is merged with operator-provided curves. Geomechanical outputs are generated, followed by petrophysical properties. To summarize the hydrocarbon, a facies analysis, grouping rock types based on their different geomechanical and petrophysical properties, is displayed. Cordax's proprietary zone tuner software provides an efficient solution that allows you to tune your horizontal. The zone tuner software constructs your completion strategy by automatically adjusting stage and cluster layouts based on the acquired log data, and this data allows you to utilize techniques such as extreme limited entry or Cordax's geologically oriented limited entry methodology. A reduction in stress differential within each stage becomes apparent from the summary plot comparing the tailored simulation to geometric results. Cordax is precisely what you need. Cordax moves the needle for your business.
So that was a short view of what we do and how we do it. From just a measurement perspective, what we're able to get inside the collars is a triple combo, which is resistivity, formation density, neutron porosity, and spectral gamma ray and traditional gamma ray. What we do is we take the data, we provide a petrophysical analysis, which really gives a lithology analysis, calculates Young's modulus and Poisson's ratio. From that, we can create a continuous compressive stress curve across the lateral and look at your porosities and saturations and really just take your geometric frac design, tweak it, and make it a little bit better. And that's what our whole value proposition is. And at the end of the day, you can go from a pure geometric frac to an extreme limited entry frac done geometrically, or through goal, tailor it to match your geology. And you can take a small investment and very easily get a 3 to 4 time return on investment by doing this. versus getting no data and just going geometrically. And that's really something at current oil prices and management mandates. It's something we all have to do. We have to get better at applying efficient technologies to get better results. Does it work? We do have an example that I'm going to step through quickly. That is a Delaware Basin, Bone Springs example. These are 2 wells that we did for a client that are on the same pad. And this is the zone grader interpretation. And without spending a huge amount of time on it right now, the thing I'd like to point out is how different these 2 wells are from each other. And if you don't get data, you don't know. And the interesting findings, particularly in well 1, was some very major variability in compressive stress across this lateral, that if a geometric frac is performed, you're fracking across major changes in compressive stress, which A, limits cluster effectiveness, and B, can be a leading cause of screen outs. And a screen out, it doesn't sound like a big deal, but it's, $200,000 to $300,000 or $400,000 to fix. So if you can eliminate one of those in a program, you just paid for the logging. This is just a look at the 2 wells that were in the same target zone, and you can see how different the facies analysis was on the 2 wells, and they weren't that far apart. So don't get any data, you don't know this, but if you get data, you can plan around it. The well 1, the interesting thing, this is the what we call our zone tuner representation, and the blue curve is the compressive stress. And you can see in this particular well, you really had multiple stair steps of consistent high stress to low stress to high stress to low stress, etc. And we plotted the geometric design, and you had 8 stages at least that crossed these compressive stress boundaries, which by just matching the stage placement, you can get a much better frac design. So that's what we did. Is we really, in this first step, was to just take the same number of stages and move them to fit the geology to where the stages didn't cross these boundaries. And the net result, which again, if somebody wants to go through a detailed discussion, was much lower frac gradients than the geometrically fracked across these boundaries. And you still ended up with the same number of stages, same amount of proppant, but a much more efficient frac operation. Next step is really, okay, what can we do to take that design and make it economically better for the operator? And what we did is really grouped the areas of the lake rock, and where appropriate, increased stage lengths. And in some cases, we increased stages up to 400 feet, but we kept the stages in the same facies type and the same rock mechanics properties. And at the end of the day, we were able to take 40 stages and turn it into 26 stages. So you reduced in this design 14 stages and had more clusters per stage, but ended up with the same number of clusters. And at the end of the day, that is a significant reduction in cost. And in this particular example, took the completion costs from $3.8 million to $3.2 million, which included the cost of doing the logs. So if you can emulate this on a program basis and start saving $200,000 to $400,000 per completion over the course of a program, you have some very happy investors. Next step is, okay, how can you prove this? How can you evaluate cluster effectiveness? And traditionally, we look at fiber optic data acquisition and interpretation, tracers, chemical, radioactive, each have benefits and each have costs and each have issues. You can go to tractor downhole videos. You can set in a program of offset pressure monitoring. And all of those are very good, established, proven technologies that can cost a lot of money and take a lot of time. So you don't get real-time feedback. What we've done is added to our repertoire of a new program called the Cluster Efficiency Log, which is really taking our data in the open hole, helping plan the stage placements in the goal program of matching the frac design to the geology, and then frac it, treat it, drill it out. And as you drill it out, if you're drilling with stick pipe, we can run our tools with basically an after frac log and compare it to the open hole log and give you an idea of which clusters took fluid and which ones didn't. And basically we run the same tools, sans the resistivity. Resistivity will not work through stick pipe or casing, but we can still get density, neutron, and spectral gamma ray. And really, we're able to determine which clusters took the frac fluid, and also, for the first time, get an idea of what's going on with the cement job. And we do that with a 3-detector density tool that allows us to both have a look at the formation and have a look at the annulus behind the cement or the casing. And it's not a cement bond log, but the inputs are the LWT measurements, both open hole and cased hole. We do look backs with the frac pressure data and offset pressures, take into effect the cementing data and the completion design, and come out with an output of a cement density log and what we call our cluster effectiveness. And really, once we get to that point, we can calculate a cluster effectiveness curve and really look at which clusters took fluid, which ones didn't, and use that on the going forward as a way to continuously improve. And the advantage of doing this is, again, goes with the theme of very low cost, low risk, and effectively real-time results, so you can understand how you did. And again, I will offer it to anyone who wants to go into a detailed presentation, but this is one of the displays that you can really look at, how good of a cement job do we have, and what's the distribution of fluid. And you can see in this particular case that over this stage, you had a variability of which clusters took the bulk of the fluid, which ones didn't, and really look at, okay, this is how I did, how do I get better? And that, again, this is a very cursory overview, but just to introduce that we have, it was an idea at the beginning of this year. We've tested it in the DJ and have some really good results. And we have 2 projects, one in the Bakken, one in the Permian that's coming up imminently. So by the end of 2020, we will have multi-basin examples of doing this. And at the end of the day, for very low cost, you can get very valuable answers to improve ROI in the wells. So again, it's with the system, we say see the rock versus not logging at all, where you don't have any data. Understand the rock, it changes. Even in wells you think are completely homogeneous, there are layers and there are changes. And if you take the time to understand it, you can frac with purpose. And the whole point of that is you design your frac to save money. And at the end of the day, that's, if you can get same or better results, spend fewer dollars, your money ahead. So I kind of sum it up with, as a business person, why not try to improve your well ROI if you have a chance? And understanding geology is not new. It's, there's folks that are new to the business that don't remember logging every well, but there's a lot of us that do remember it. And we've been doing it for over 100 years. We stopped doing it, particularly in the laterals, because it was expensive and risky. Now it's not. And there's a way to optimize cluster effectiveness. If you decrease one screen out of a program, you just paid for the whole logging program. And by not viewing this as a science experiment, it's part of the workflow, you can continually get better. So again, low cost, low risk, little rig time. And if you feel and you believe that you have to figure out ways to do things different to win, this is one, in my mind, no-brainer way to do it. So thank you for your time. Again, my contact info is on the cover page, and I'd be happy to talk to anyone in detail, and see you in the field.